Great. So welcome everybody to the Anchore open source virtual meetup. I think we have a set of interesting talks today. We have a little bit of bookkeeping we'll get through, but looking forward to this. We're going to take kind of a loose approach with the talks. So we'll do Q&A after each talk. So if you have any questions, you can get them in the chat, so the speakers can address them afterwards, or we can kind of have a Q&A session directly after each talk. I'm sure there'll be some interesting questions. We've got some good stuff coming today from Dan Luhring from Anchore and Dan Lorenc from Google joining us. We'll get into that in just a moment. So please, housekeeping stuff. Try to mute your line. If there's noise in the background, just makes it easier for everybody else to follow what's going on. Like I said, we are recording this, and there will be an email that will follow up afterwards for where to get the recording. Usually those land on YouTube, but the email will have the details on where to find it, so you can watch it again or pass it around to other folks that couldn't make it. And yeah, we definitely encourage kind of interaction and chat during the meetup. So feel free to use the Zoom chat panel to converse, and we can, the speakers will keep an eye on this. I'll keep an eye on it and see if there's any questions we need to address towards the end, and we'll make sure we get to those. So we have a pretty straightforward agenda for today. We'll do welcome, introduction, and we're going to kick off a poll here towards the beginning, and the poll is around an in-person and in real life meetup at KubeCon. So we just want to get a sense for how many folks would be joining us, and who is able to attend KubeCon this year in Los Angeles, like in person. So we're going to open that poll now. So Brian will kick that poll off, and it will stay open through the talks, and we'll close it at the end and share the results. So that way, if people join a little late or whatever, they can contribute. I'll do a quick reminder in between the two talks to respond to the poll if possible, and so folks can find out, but that'll help us with our planning, and hopefully we'll see folks at KubeCon. Anchore will definitely have representation there. We may see Dan Lorenc there as well, I expect, hopefully. So looking forward to that. So the main event today is a couple of talks that I'm excited to hear about. Starting us will be Dan Luhring talking about smarter ways to get data out of Grype. So kind of using the rich data output that Grype gives directly, and then how to format that, how to use that to integrate into your pipelines and the right format and data that you want. And then Dan Lorenc from Google is joining us. He's been instrumental in driving the Sigstore project, and he's going to talk about some supply chain security with Sigstore projects and using Syft. So looking forward to that as well. Then we'll wrap up. We have some additional kind of general discussion time and some potential topics if we have time and if people are interested. Like I said, we also have some additional time in our schedules towards the end of this, after another 30 minutes, if we want to go over, if there's really good discussion and people want to hang around, we're open to that and can help facilitate that. But we'll plan to end the agenda on the hour. So we'll go ahead and get started. So Dan Luhring will be taking us through the first talk. Reminder to Brian to fire off the poll here so folks can have time to respond to that. And to be clear, that's the open source in real life meetup at KubeCon in Los Angeles. So, and then I will hand off to Dan Luhring. If you want to go ahead and get your slides ready, I'm going to talk about Grype output formatting.
Sounds good. Yeah, I'm ready.
I will stop sharing.
Oh, nice. Momentary grid of a bunch of people. Okay. So hopefully you can see this. I'm moving the Zoom controls out of the way. So anyway, yeah, this talk is smarter ways to get data out of Grype. And we'll talk about what we mean by Grype and what we mean by data. We don't mean this data, although we can if you want to. But really quick, my name is Dan Luhring. I manage the open source engineering team at Anchore. The icons are kind of dim here, but definitely if you want to follow up with me, please do so. I have a GitHub Luhring. On Twitter, I'm Dan Luhring, and you can also feel free to email me. We'd love to follow up about anything we're talking about today or anything Syft and Grype. So my team's the one that maintains Syft and Grype. So moving right along. Grype, what is it for anyone who doesn't know? Grype is a vulnerability scanner. And in particular, it's a vulnerability scanner for SBOMs. It's interesting because a lot of people are using Grype to scan container images, and Grype can also be used in workflows to just scan file systems or a local repo or something. But when you think about it, the real correct abstraction for what how vulnerability scanning works, regardless of which tool it is the SBOM. It's this list of packages with information about each package that can be used to figure out if this package matches up with a known vulnerability that's been reported somewhere. And so a lot of vulnerability scanners that are doing this sort of thing have an implicit SBOM. So they're being pointed to a container image, let's say, and under the hood, they're generating an SBOM-like data structure because they need to understand what software is installed in that container image. But then what they're showing you is just vulnerabilities. And the Grype takes kind of a different approach. It can do just-in-time SBOMs internally if it needs to, but you're also SBOMs are a first-class citizen with Grype. So there's a companion tool, Syft, that some of you've heard about, that we also maintain. And so Syft can produce SBOMs that are useful for a number of reasons, not just for vulnerability matching, but you can actually feed that directly into Grype. And we'll take a look at that in a second. But in general, Grype does get used for container images. You can run Grype from within a running container to see the containers file system and scan that for vulnerabilities. You can scan just regular files on your machine or on a server or whatever. Ends up working out really nicely. And here's a link for more about Grype. I'll have another link slide at the end, though. Really what Grype is, if you think about it, is it's a data tool. So Grype, most of the logic of the Grype code base is just intensive data processing. And so there's an input and output to this equation. On the input side, there's actually two things that are primary. One is the SBOM, which we just talked about, and the other thing is vulnerability data. Now with Grype, it ends up managing a lot of the vulnerability data side of things for you. So, so my team's responsible for building and publishing vulnerability databases that Grype consumes every single day. So there's new data every single day being made available. And behind the scenes, Grype is accessing that data, pulling it locally so it can do a super fast local analysis on your machine. There is configuration exposed, so you can see what it's doing and kind of change how it's behaving if you'd like to, but in general, you don't have to worry about that. But nonetheless, it's still a first-class input to what Grype's doing. So what's the output? The output is really rich analysis data. And that's what we're here to talk about today. I just wanted to set this up. So Grype has really rich SBOM information that it takes in, really rich vulnerability data. And as you might expect, the output is really rich analysis data that shows you the pairings between identified software packages and published vulnerabilities. So to show what I mean, let's go to a demo. Can everyone see the terminal? Sweet. Big enough? So anyway, let's look at how this might work. So the first thing I'm going to do to kind of show off that SBOM concept that I mentioned is actually run Syft to generate an SBOM on an image that I've made. It's just a dummy image that I know has a lot of vulnerabilities, and that'll be really useful for when we want to look at the data that's coming out of Grype. So we'll do this. Yep, you can tell I've run this command already. So we're running Syft against the image that's just local to me test latest. And we're using that output switch so that Syft is going to generate really rich JSON output. And we're going to save that to disk. I'll just call it test.syft.json. So we'll run this really quick, and that'll give us an SBOM. We won't see the package information here. Of course, it'll be written directly to disk. And we'll use that as an input to Grype. And that'll be a really great springboard for the Grype features I want to show off. Something interesting to note is that you can feed an SBOM to Grype. You can feed an image reference from your local Docker daemon or from a registry. And it ends up being really powerful to use SBOMs as an input, because what that means is the analysis is much faster because it doesn't have to spend time pulling down the image from the registry or loading it from the local daemon. And it doesn't have to spend time unpacking that image to see all the layers and do the merged file system and then start analyzing from there. So SBOMs are kind of a lossless representation of the input that Grype needs based on that container image. So anyway, it's just a really nice pivot point because then we can show off Grype. So cool. So now we have this SBOM on disk here. So we'll start feeding that to Grype. So we'll do Grype. You can tell Grype explicitly use an SBOM that's already on disk somewhere. So we'll feed it this SBOM, and we're just going to run this without any special output options for a second and see what it does. Okay, so you can tell that it found some things. This list is very large. I'm scrolling up. Let's see if I can see the top. No, I can't even see the top. So the top has scrolled off, out of my buffer. And there's a ton of vulnerability matches being shown here. You can't see the headers because they've scrolled off, but what this is showing, if you don't know, is this is the package name, then we have the package version, fixed information that we know about from our upstream data sources. Either we don't know anything, or it has been fixed in a later version, or the vendor has explicitly said that they're not going to fix this vulnerability. We have the vulnerability ID, and then the vulnerabilities severity. So this is useful to get kind of a summary view of how bad you are in terms of known vulnerabilities with your image. But it turns out that Grype knows a whole lot more than this, that it's not letting on in this output view. And that's what we're going to talk about here. There's a few output options for Grype. So if I go to Grype and then just look at the help, you can see a few of the flags we have here. The one we're going to talk about here is this output option. So you can do -o or -- output. And there's a few options for values you can provide. You can, by default, it's table, but you can be explicit about that. You can output cyclone.dx. But we're going to talk about today is specifically JSON, and also we'll get to the template output as well. So let's take a look at the JSON output. Okay, so that's a lot of data. Okay, it's still going. All right, it just finished. So you'll notice that's a lot of data, and just scrolling up a little bit, you can tell that there's all sorts of stuff being shown. Some of it may or may not be relevant based on what you're trying to do. But you can tell at the bottom here, we actually kind of introspect the image itself. We talk about its layers, its size, references to repository URLs. And then you'll see some vulnerability data up here, but I kind of want to make sense of this because this is a lot here. And the first thing I want to talk about is this tool called JQ. So if you haven't heard about JQ, I really want to pitch it to you and see what you think, because JQ is for querying and manipulating JSON data. I first found out about the JQ tool probably like 7 years ago or so. And at the time, it was this awkward, like necessary thing I had to use for what I was trying to do in a workflow. But at present day, I'm in love with JQ. And so I want to show you a little bit about what it does that I really think is cool. The first thing I'll do, just to save time, I'm going to write this to a file. We'll call this Grype.test.json. Oops, I want the JSON version of it. Actually, you know what? I think I just have to do this. 1 sec. Demos. Okay, cool. So Grype, this, we'll get the JSON format. This way we don't have to actually run Grype again. We can just use the result of running Grype to show what we want to show. So here I'll look at this output, and I'll just show you, first I'll just show you JQ itself. So if I do that, then I can just type JQ, and then I like JQ even without any options because you can see that it's doing some syntax highlighting. So it's identifying these objects, their keys and their values. And this is still a lot of data. So what I'm showing you now is not a whole lot better than what I just showed you, but it ends up being really nice for exploring the data in a little bit prettier way than comes directly from the tools. And so one thing you can do is you can pipe this to less and maintain the colorization. And so you can use less if you're familiar with less and kind of control how you're looking at this data. You can use less's searching functionality, so you can look for certain keywords and stuff. And so I find this really useful. So at the very minimum, if there's a takeaway here, I want to talk about the value of using JQ paired with Grype's output. And the same things end up applying to Syft's JSON output as well. But so what can you do with JQ? I mentioned it can be used for querying and data manipulation. You can end up passing in these filter strings that describe what you want to do with the JSON data. So one thing you might want to do to get started is just find out what's here. What are the high-level object keys? So you can just pass keys, and it'll tell you, okay, for the object that it's receiving, it's going to show just the high-level keys on that object. So matches is where the main event is, and we'll talk about the matches property that ends up being a giant array of vulnerability matches. But it also shows other things like we were talking about with more about the image, which is the source, more about the tool itself that did the analysis, that's in the descriptor section, and the distribution it identified for the image. So now let's look at actual matches. So we can access properties on the object. We can do something like matches. We can pipe that to a length function. And I'll just point out that if this is hard to follow, there's really great documentation I wanted to show. So this is the homepage for JQ where you can download it. You can also just use Homebrew to install it. But they have really great docs, and I'm referencing this page all the time. So it can show you all the different filters you might want to use for accessing properties or certain array indexes, how to chain multiple filters together. So I just wanted to point this out. And this link is in that links slide I have at the end that we'll send out. So you don't have to memorize this URL. But so what you end up doing, yeah, we can see the length of this array. So, oh my gosh, we have 1,751 matches total. We can start to look at this. So let's look at just, we can map each vulnerability match to just the artifact name. So we could just see the name. I'll pipe that to less, oops. And so now we can see all the list of the software that's vulnerable within what I scanned. I can then, if there's duplicates in that list, I can pipe that to unique to kind of get the distinct list. And it'll actually automatically sort. So I have a list of vulnerable software here that can be useful. But then what you end up being able to do is really do some creative manipulation. So you can map these vulnerability objects to new objects where the data shape is what you define. So you can say, inside this map, I'm going to create a new object. So instead of showing me all the noise that comes with Grype's raw output, I say noise. It can be useful to you depending on what your needs are, but usually your needs are such that some of it's interesting to you and the rest is not. So in that situation, you can create sort of a compact view. So like I could say, I want to create new objects, and I'm going to have a package field on my object that's data is sourced from Grype's output at artifact.name. Maybe we want to have the version. So that's going to be present. I happen to know where it is in the Grype JSON. And let's see, maybe the CVE ID. So that is found for this package. So I could do CVE, and that's going to be accessing vulnerability.id. So now I can run this, and just to clarify, we're passing in that matches array that Grype has and mapping it to my own array that I want to define that has these fields instead. And so this is what that looks like. So you can start to see how I'm creating new data structures, sourcing data from what Grype gave me, but in ways that might be more meaningful for me, either as a human, because I'm just interested in a more focused triaging of the vulnerabilities that are in my software, or it can be used for getting exactly the format you need for downstream in a machine workflow. So if some other processing needs to input JSON, but not Grype JSON, maybe it has its own needs, or you need to do some transformations, it's great for that. And the last thing I want to show in the talk is you might imagine that with all the filters that you can apply and all the various kinds of data you might want to construct, JQ can be really cool for quickly finding out some information about your JSON data, but this can start to get unwieldy over time, especially if you're interested in a very particular format and you understand the format you want, but expressing it in JQ might be cumbersome, and also you wish there was a way to persist that new format. So a few months ago, we added something that's really powerful into Grype, and it takes advantages of Go's templating engine. So we saw that there's different -O options for Grype. The one I want to focus on just really quickly is the template option. So if you're not familiar, several tools are doing this now, but they're taking advantage of the templating syntax that's built into the Go standard library. And so this is documented here. And again, there's a link for this in the slides. But you can start to put together really powerful template files, and these are text files that use this syntax to define a certain format, and it accesses objects and properties that come from some data structures, and those end up being the same data shapes that you saw in the JSON output. So it's really nifty because you can now create a persisted file that you can check into a repo that defines an output shape. And it might be that you want a particular format and Grype doesn't know about that format. That's okay now because you can create this template. And even if Grype doesn't know about the format that you want, you can define it yourself and use that. And then it's as if Grype knew about that format. I'll just show that really quick. A really quick example. I had, I wanted to use Grype's output in CSV format. And so Grype doesn't have a -o CSV option, for example. So what I was able to do is create this CSV template file. And this is just using that syntax from those docs. And again, I've linked to that in the slides. So I can just kind of represent that data structure I want here. I want like a header row where I say package version CVE. And here I have a syntax for ranging across that matches property. And you can tell that these are pretty much exactly the same names as we saw with the JSON. It's just you'll notice these start with capital letters because they're actual Go structs and properties. So for each match, we're gonna grab this artifact name, the artifact version, and the vulnerability ID. And then we're gonna close that loop. So what does this look like? We'll take Grype. Here we go. So just to clarify, we're having Grype look at that SBOM. We're choosing the templating engine for his output, and we're passing in a explicit template of csv.tmpl. We'll pass that to Les just for readability. Boom, here we go. So we have nice CSV data. We could have written this to disk or passed it downstream to another data consumer. But this is a really nice way to create a format that Grype doesn't know about offhand. We found this to be hugely powerful on our side. So recently we did an integration with GitLab's container scanning feature, and GitLab has its own ecosystem where there's a particular container scanning format for reporting vulnerabilities, and Grype doesn't support it natively, but we were able to really quickly define the GitLab template in the template file, and then pass that into Grype, and then Grype can just immediately pass data that's in the correct shape from the get-go, as opposed to having Grype write its output to disk somewhere, translating that, etc. We've had a lot of interest in the templates from the community. We had someone last week show us a really cool web page that had been rendered. It's using the Go templating syntax, but accessing Grype's data to render a full HTML web page. And one thing we've talked about recently is having the templates actually saved in a kind of a reference directory within the Grype repo, so that folks who are interested, even if we haven't baked it into one of those -o options, we still have a list of templates that might be of interest to you. So with that, that's all I have. Get back to the slides here. We'll send the slides up, but this is the links that I showed today in case you're interested. And that's all I had. Thank you so much.
Thanks, Dan. Appreciate it. We had a few questions, so I've been watching the chat, and we've answered a few while you were talking, but I wanted to bring some up that you can respond to directly for sure. One from Mikey is the Syft JSON output format an Anchore specific SBOM format, and can Grype use Cyclone DX SBOM as input as well?
That is a fantastic question. The short answer is that this is like what we're focusing on next. So right now, the Syft JSON output is proprietary to Syft. It's basically a JSON representation of the Syft business objects that it uses. So it's proprietary. It has a lot of information. I mean, it basically has complete information about what Syft knew about during the analysis, but it ends up being a proprietary format, which we realize is not ideal. So on the Syft side, we already support various standards like SPDX, and we're working on expanding that on the Syft side. But to complement that, to your point, Mikey, yes, we're working on having Grype take various standard formats like Cyclone DX and SPDX as input in addition to the Syft SBOM format. And we think that's going to be really powerful because we see like the ecosystem having more tools where what's ending up in these repositories or registries are actual standards-based SBOMs. And we'd love for Grype to be a really great consumer of that information and really valuable to people who are using that data downstream in their security workflow. So great question. Short answer is we don't yet, but we want to get to it really soon.
Great. We had one other question from Keira. I'm sure I've mangled that name. Apologies. Which is, can you show an example where Grype detects vulnerabilities that are not bundled with the OS distro?
Sure. If I understand the question, there's multiple kinds of vulnerabilities that we can detect. There's certainly OS distro vulnerabilities like Debian. Maybe that was showing in the JSON output in my example. But we also detect vulnerabilities for language ecosystems. So there's vulnerabilities specifically about npm packages, for example, or Python packages or Ruby gems or Maven packages or whatever. So there's vulnerability data not just about like distro package manager packages, but also things from other ecosystems, like for various programming languages. I can share that, or if that's satisfactory, you can take my word for it.
Yeah, maybe we could follow up towards the end, so we could, if you want to do some more screen sharing at the end, we certainly we'll have some flex time there. We circle back on that if we want to.
Sure.
Great. Okay. Unless there's any other questions, I think those were the main ones that we didn't provide some chat response to. Dan can look through the back scroll and see if there's anything he wants to chime in on. Oh, from Chris. Can Anchore also do licensing scanning to make a complete SBOM? Dan, I'm asking. Dan Luhring, I'm asking that question for Chris. Yeah.
Okay, yeah. So that would be more on the Syft side. Yeah, so Syft right now, part of what it detects as it's generating the SBOM based on packages it's finding is, if possible, shows what license applies to that package. And I believe it's actually an array in case it detects multiple, and it reports that in its output. I think there's more features we have in mind, but this would be great to ask the community about, like, what to do with that information. Do we want to vet the license claims based on license text or whatever? And do we want to enable more reporting based on that license data? Those are things we're thinking about for the future. Mm-hmm. Does that answer the question?
I believe so. I think we have some more interesting questions coming up. We're at Jorg is asking about some, looks like, false positives. Let's so we can get to the next talk and make sure we have enough time for Dan Lorenc to present. We can interact with those on Slack, or sorry, not on Slack, in the chat window, and then circle back if we have time at the end to talk about those topics more interactively. I think they're great questions. We want to get to those, but I want to make sure that folks that have to leave at the top of the hour, that we can get through the rest of the talks too. So excellent. Keep the questions coming. Much appreciated.
Also, I'll just say, sorry, Zach, but definitely in case, worst case, we don't get to it in the Zoom chat, definitely follow up with us offline. Like, there's an Anchore community Slack, anchore.com/Slack, that we're in all the time if you want to ping us there. And also the information that was in the slides about us on email or Twitter or something.
Yeah, great. Thanks, Dan. Okay, one more reminder that we have the poll still open. So if you haven't answered the poll question, please do so. It's just about if you'll be around for KubeCon LA in October here in Los Angeles, California, and if you'd be able to attend the in real life meetup. So I'll just plug that one more time. And then without further ado, we will go straight to Dan Lorenc, an engineer from Google, who's very much involved in driving some of the Cosine and the Sigstore projects from the Linux Foundation. And he's going to walk us through kind of those projects and some supply chain security stuff with Syft as well. So Dan Lorenc, you have the floor.
Awesome. I should be sharing my screen. I've got the whole screen shared. I've got a couple slides I'll go over, but I'm also going to jump back and forth between terminal and do some demos and stuff too. My talk also features JQ quite heavily. I think I use it all the time without even thinking about it. So thanks for giving everybody an overview on JQ right before this. So I'm going to be talking about the Sig project and doing some demos and showing how to use Sigstore and some of the tools there that are for signing containers with Syft and Grype to get some useful supply chain security protections on your SBOMs if you have them. So I guess I've got the whole screen, but I'll do full screen mode just for the slides so they look a little bit nicer. Cool. Yeah. So quick overview of Sigstore. I've got a couple slides. There's a lot to Sigstore, so I'm going to go over it quickly, and I'm sure there will be some questions. But if you have any, you can hop into our Slack or read some more at sigstore.dev. Has a bunch more on the architecture and how all the pieces fit together. Then I'm going to show how they can be used with Syft and Grype here, and then jump to some demos combining it all into something useful, hopefully, if they all work. So the overview and kind of the mission of Sigstore, I like to start with this story. When it comes to supply chain security, most people know and have been yelled at by their IT teams and security orgs by now that if you find a USB thumb drive on the sidewalk or on the street outside of your house or your office, you are not supposed to pick that thing up, take it inside, and plug it into your computer. That is really, really scary. It's pretty obvious at this point because so many actual attacks have happened this way that even in sensitive buildings, they even block off USB ports so people can't do things like this. So this is a no-brainer. Don't do this. Hopefully everybody knows this and this isn't a surprise to anybody. But when it comes to using open source software, there's not really much of a difference between plugging a USB drive you found on the sidewalk in and doing something like npm install a package name. This isn't even specific to npm. Any package manager in any language you install is typically coming from someone you've never met. You have no idea what's in that code. It could be malicious. And attacks are happening more and more often like this, where Bitcoin mining, ransomware, credential stealing code is getting inserted into open source packages, and then people are getting tricked into installing it. So this is pretty scary, and the root of the problem is, we can't really verify where it's coming from or who produced the open source code. So it's a pretty easy target for bad people to slip malware in. So that's kind of where we started with Sigstore. Let's pretend we could, if you imagine a world where that is safe, pretend you could find some random source code artifact on the ground. What if we could actually, from that artifact, look up and find all the metadata in supply chain about where that came from and verify it? So plugging in a USB thumb drive would be safe. Installing an open source package, assuming you verified all of this and trusted where it came from, would also be safe. So that's kind of what we've been building in the Sigstore project. There's a whole bunch of different components that fit together to start making this possible, but I think we're getting close, and I'm excited about it. Here is the most of this demo is going to be going over the cosign tool, which is a pretty easy way to get started with the rest of the Sigstore components, and it's what we'll focus on today with our demos because it's dedicated to signing containers. Container sign cosign, that's how we got the name. It can, like the name says, it can sign your Docker container images. It works with containers on every OCI compliant registry we've tested it with. You can sign it with a whole bunch of different types of keys. You can use YubiKeys. You can use KMS systems on pretty much any cloud. It is built into a whole bunch of different transparency logs, which I'll show in a little bit. You can do fancier stuff instead of just plain signing containers using things like the update framework or TUF or in toto attestations, which I'm going to be showing a bit more with the Syft and Grype SBOM demos. And then there's even a cool version of signing that doesn't use any keys at all. When it comes to signing packages and code, one of the biggest problems is keeping your keys and not losing them and not having them stolen. So there's some modes we built in to Sigstore involving all these complicated systems, which I think are on the next slide, to make that all work. And I'll do a couple of quick demos of that too when I switch over to my terminal. This is kind of the overall architecture and all the different moving pieces it takes to do that keyless signing stuff I talked about. We don't have to go through all of this because this is a pretty short talk, but if you go to sigstore.dev, there are much fancier diagrams explaining how it all fits together. Under the covers, though, it's not really keyless. There are keys involved. They're just managed for you, and they're generated quickly and deleted, so you don't have to worry about it. But if the serverless people get to call serverless, even though they're servers, then I think it's fair for us to kind of steal that buzzword and call this keyless. So let's jump to some demos, I guess. We'll start with the cosign demos, and then I'll come back and talk about how it works with Syft and Grype and SBOMs. The cosign tool is here on GitHub. This is where I started. Actually, so it's github.com/sigstore/cosign if you want to follow along or try this out yourself. All you really need is this tool and then some containers in a registry. And there's instructions on how to get started and install cosign down here. I will open up my terminal, make it a little bit bigger. Hopefully this is big enough for people to see. Awesome. So I've got a container in a registry. I'll show what this looks like. There's another tool, which is really cool for working with containers and seeing them, called Crane, which I use with JQ all the time. So I'll show my image here. Container images are really just JSON and tarballs stitched together. So I'll show what that manifest looks like here. First, type that to JQ so it looks pretty. Boom. So here's a single layer container image that I have in my registry. You can have a bunch of layers, you can have a bunch of different things. And I've got an Alpine one we'll use later for some SBOMs. But this is the one we'll start by signing first. When you want to sign with cosign, the easiest flow is to generate a key here locally. So we can do that. I'll do cosign, generate key pair. There are no flags. You don't have to worry about algorithms or anything like that. You type in a password here. What did I type? Cool. I've got a public and a private key, which is basically how signatures work. If you want to look at these, I can show you what they look like. Here is the public key. It's pretty short. This uses basic EC, DSA, or elliptic curve cryptography, which is compliant with all the different government regulations, and it's supported by most of the different hardware things and cloud providers. So that's how we settled on this algorithm. Pretty short. This is the public key. If you want to verify stuff, this is what you hand to your end users to do checking of your signatures. The private key is right here. This is normally the thing you want to keep private and not show people, but they're actually stored encrypted. So you don't have to worry if it leaks or anything like that. You need the password to use this. Because it's encrypted, it's not a huge problem if you accidentally check one of these into a Git repo. And there are even some nice flows you can do just by checking all of this into a Git repo and keeping the password somewhere else. So you can do signing in CI and rotation and fancy stuff like that. A lot of other systems store them unencrypted, which means eventually somebody's going to forget, check it in, and you're going to get some angry emails and have to rotate your keys and stuff. So let's use these to sign my image. One flag here, which is the key, and then the image name. I'm using GCR for this, but you could use Docker Hub, Quay, and the other registries. My password. So now it is signed, and the signature has been pushed up to the registry. Anybody with that public key could now verify the signature. Pass in the public key here. No typos. And it got verified. Awesome. So it printed out all the stuff we checked. Here's the signature itself. And this is just more JSON. So you could pipe this into JQ and look around at it. But the signature payload that we sign just has the URL for the image and the digest of the image in here too, by default. So it doesn't really say much. It doesn't say why you signed it. It doesn't say what commit it was built from or anything like that by default. You can add cosign. We support annotations, so you can do the -a flag and add some key value pairs here. I'll say foo equals bar. If you're doing this for real, you might want to pass in a git commit, a tag, a version, something representing exactly what software went into your container image if you're building inside of CI. So then you have some more metadata you can check later. What we can do now is if we verify, we'll see that there are multiple signatures here. Sign it twice and then get appended to each other. Yeah, so there's two signatures. Let me pipe that to make it a little easier to read. Cool. So here's the first one. It says what it is. And the second one, we can see that foo equals bar pair. And if you want, you can check that here during verification, and it'll only print pairs that match that. I'm doing this verification here locally, but there are a bunch of different admission controllers if you're trying to deploy to Kubernetes or different runtime environments to do this automatically. So you can have a list of public keys that are allowed to deploy, and it won't let you deploy things unless the images have been signed. So here are the basics. This is the simple flow with keys. If you wanted to use a KMS system, you could set that up yourself too and set up off to the KMS system instead of generating the key and having those files locally. I'll do one more quick one, which is the magic keyless one. This is still experimental. So I turn that on, and now we can do all this again, except instead of passing a key, we just won't pass one here. And now we'll see this cool flow. We're actually going to sign it with an automatic certificate we're going to retrieve from a Sigstore service that is authenticated against my email address. So we'll go through a little browser flow here if this all works. Cool. So I'll go back here before I click OK. We generated keys here in memory, so they never touch disk. They're random. Get a certificate based on those keys from the Sigstore service. And now we have to authenticate with an email address. I'll do that. Click this. It does the OpenID connect flow, proves that I have access to that email address, stick some stuff into a transparency log. which is cool. And now it's signed again. Verify here, we should see no keys again here. It's going to go through JQ. Terminal mode that just always does JQ when it finds JSON. Yeah, so same payload up here before. We've got the certificate in here, base 64 encoded, and then my email address, which is the one I did the OpenID Connect flow through. So it all got signed again with no keys this time. So you can verify it and just tell people your email address and they can check and prove that you signed things and you don't have to worry about losing keys. So this is some basic primitives you can use to start to build up supply chain security. Signing by itself doesn't really get you security. It kind of lets you build up your own flows and permission models. Let's talk about how there's a whole bunch of different ways you can use this, for gating deployments to production and stuff. There are also some cool flows involving SBOMs, and that's where Syft and Grype come in. Talked about SBOMs before. They contain all of the information that goes into a binary or a container, software bill of materials. There are a couple different formats. Whole bunch of tools for producing them. Consumption is just getting started though as people start producing them. So the biggest use case so far is knowing what vulnerabilities to watch out for. And that's where I really like the Syft and the Grype flow. A lot of image scanners kind of combine those two, like was shown before, where you scan and you get vulnerabilities. But that doesn't really make sense because the SBOM components, the things in your container, don't ever change. They get stuck in there once, and the container image is static and immutable. So why bother downloading and extracting and scanning that container every time? You can produce that SBOM once at build time, and then do a whole bunch of different things with that SBOM, which is way easier to do than downloading the container each time. So with Syft, you can produce an SBOM, and then with Grype, you can check what's inside of it. If you're signing your images and the SBOM is produced at the same time you sign the image, it probably also makes sense to sign your SBOMs. Otherwise, the SBOM could get tampered with. And then if you're looking at the wrong contents, then that's a problem too. You might not look at the right packages to see if there are vulnerabilities inside them. At the same time, vulnerability data isn't static. Right? If you scanned an image a year ago and it had no vulnerabilities in it, it's not that useful because vulnerabilities get found in software all the time. So you have to constantly scan and look for this stuff later. So there are a couple different tools in Cosign for working with SBOMs. If you have, say, something in the SPDX or the CycloneDX format, Cosign can store those SBOMs in your container registry too, and then you can sign them just like they are images. Let me see if I can get this command to work and remember the syntax. So I have some SBOMs already sitting here, I think. Yeah, cool. So I use Grype to generate, Syft to generate an SBOM in the SPDX and the JSON format here. So let's look at it's going to be huge. Yeah, so these are all the packages inside my Alpine container that I generated earlier. We can use Cosign to upload this, so it's not just sitting here in my local directory, but it's uploaded next to the container image that I generated this from. See if I can get this to work. That, and then the name of the image. And this one was for Alpine. Got that right. Awesome. Yeah, so this uploaded the SPDX SBOM to container registry, so it's sitting right here next to the image. So if anybody that wants to pull this image can also download the SBOM itself. You don't have to worry about storing them somewhere else if you already have a container registry. Download SBOM and then that image name. And boom, it spits that back out. So this is a nice way to distribute your supply chain metadata next to your container images. And then you can sign it with the same keys or different keys if you want to. And this was generated using Syft earlier. Yeah, that was the command I did, except I had -o SPDX instead of JSON here. For JSON, I'm going to show a different flow that involves the scan results here. And this is a feature in Cosign involving attestations. I don't have a great slide on these, so I'll try to talk through it and explain it a bit as we look at them. The first signature I showed earlier, back here and show what these look like again. Since before, but the signatures don't really have any metadata in them explaining why you sign something. It's just kind of a Boolean that you sign something. What did I do? So that's not that useful. You have to make a whole bunch of implicit promises and implicit guarantees about why and when you'll sign things. You can build up some basic stuff in one of these signatures with the -a flag there, foo equals bar. But it turns out there's a whole rich data model for this already called in toto attestations. And they live here in this repo, in toto/attestation. And the way I think of an attestation is a signed statement about a subject. So it slightly formalizes those implicit things we just talked about. A statement can be anything. It can be, this is cool. I like this container. It's red, something like that. And then the subject is what it refers to. So instead of signing the container itself, now we're signing a document about that container, and we're referencing the container in that document. So that's what an attestation is. You can put anything you want in here. There are some well-known ones though, like provenance. This attestation format contains information about how a container was built beyond just the commit it was built at. We contain the build tool, the environment, the commit of all the build tools that were used to build it, that kind of thing. And you could do this for any type of artifact, not just a container. What we can also do, though, is use attestations to capture scan results. Because it turns out for compliance and a lot of regulations, you want to know how frequently your images were scanned. And you might want to write a policy that says something like, only allow me to run containers in my production environment if they've been scanned and they don't have any critical CVEs within the last 2 weeks. Because again, these results get old. So what we can do is we can put timestamps into these to show when the attestation was produced and then sign those so they can't be tampered with after they were first created. So now what that becomes is a signed statement that says, as of today, Wednesday, September 1st, 1:52, I scanned the container and there was nothing bad in it. So then later we have a record showing that we did this, and if something bad happened, vulnerability was found the next day, then we know it was good today when I deployed it, and we can kind of tune our policy to rescan and produce these attestations again later. So let's break apart that flow now. I've got the JSON version here generated from Syft. I'll redo it. This is going to get me a JSON SBOM using the Syft format here. And that I've attached the SPDX version to my container, but instead of attaching this one or signing this one, we're going to produce a scan result using Grype. So Grype can do just-in-time scans from the images, but that's not efficient, and we already have the SBOM locally. So let's produce a scan here. We'll take a look at it. I picked an old Alpine image here just so there would be a scan, or there would be something in it, so it wouldn't be empty. Yeah, there is one medium severity vulnerability. This has been patched in Alpine if you grab a new version, but in the one I grabbed, I think about a month old, there's this vulnerability here. So it's in the JSON format, save that to disk. And let's pretend our policy allowed this, so it's fine. We just don't want high severity vulnerabilities. So now we're going to use cosign to produce an attestation here that's signed with our key again and store that with the container. So we can have the command here. Here we go. Instead of sign now, we're going to attest. We're going to use this key to sign it. The predicate that we're producing is that we're using is that scan.json, and we're going to attach that to the Alpine image I have here. So this will happen. I'll enter my password again, and this all works with those same key management systems and keyless email-based flows I talked about before too. The attestation is now stored with the image, so your policy system could check this and prevent you from running these if the attestation doesn't exist or if the data inside of it is wrong. Let's take a look at what that looks like, and then there's a bunch of JQ to actually make it look good because it's JSON nested inside of other JSON. There's the long JQ payload, but we'll build up to that one. We're going to verify it. This is going to show us all the different attestations that are on that image. It's long. It's JSON embedded inside of JSON with base64 encoding. But this one was actually signed correctly by that key, so we know the data in here is at least valid. If we want to actually show what it looks like, I'll put those JQ things back. So we're going to pull the payload out of there. We're going to base64 decode that, and then we're going to take the data out. And actually, if I up here, I think we'll see the timestamp. There is a timestamp in here somewhere. Sorry, my terminal formatting is bad. Here's the full one that shows the scan.json again that we got exactly out of here. And cosine attaches its own timestamp when we actually do the signature. So here's the scan result in JSON format showing that one vulnerability inside of it, and this gets signed and uploaded with the image, so it can't be tampered with. For public artifacts, you can use some of the rest of the Sigstore components to publish these onto a transparency log, so people have a central place to discover these, and they know they're not getting a special version of this, and the version that has been distributed is the same one for everyone, so you're not hiding anything. But for private images, you can skip that and just use your own registry with your own permissions model. Cool. So yeah, that shows, it wraps up the demo, but it shows how to sign images, it shows how to sign SBOMs, and then how to use these tools to test vulnerability reports, which might start to make these SBOMs actually useful in your policy systems and your production environment. That's all I've got. I think we've got some time for questions here for people that had any while I was going. I was just talking for a while, nonstop.
Thanks, Dan. That was great. Awesome to see the story end to end. Some interesting, some things in there I hadn't seen before. The keyless stuff is particularly compelling. So that is something we've all done that before. Lost a key.
Yep.
I think there's some chat questions there. Is there,
which SBOM specifications do I prefer? They're all fine. I don't really have a preference here on the formats. The more important thing is how they're generated, when they're generated. Trying to do it as close to the build process as possible to get the most accurate data, I think, is the most important piece. Stepping through it slower. Yeah, sorry, I had to go through that pretty quick. There were a lot of commands there. A lot of this is in the, if you go to Sigstore /cosine, there's a lot of these examples checked in there in the README and docs too.
I think there's one about Sigstore authentication from Mikey.
Sure. Yeah, is there any issue using Sigstore authentication, which is based on a password, to gain a key pair? Okay, yeah, so what actually happens there is we generate a public-private key pair for asymmetric stuff, but then we encrypt the private key. So it's like a wrapped key. And so that's set up using a NACL secret box if you want to know exactly how that's encrypted. So there's no issue there. You could keep it unencrypted, and some tools like OpenSSL will do that by default. All these signatures are compatible with those tools as well if you have other systems. This is just an extra layer of protection in case you forget to ignore it and check it in and push it to a repo, which everybody's done. I've done before. So it's one more something to help you out a little bit and prevent mistakes.
Cool. So there are a couple more great questions. What I'd like to do before, because we're at the top of the hour, I want to do a couple announcements, and then we can jump back in. We reserve some time if we want to follow up, but I want, if people have to leave, I want to make sure we get a couple of more announcements through real quick, and then we can jump back if you have some time, Dan, and
Sure.
folks have some follow-ups. So here, let me share this really quick to get through it, and we'll hop back. Where did it go? There we go. Okay. So I wanted to, again, do a quick announcement. We have the open source, the in real life meetup at KubeCon. It's Tuesday, October 12th. No presentations, just me networking and getting to meet each other. Can everybody see? Dan, Luhring, can you give me a thumbs up if you're seeing the slide correctly? Okay, just making sure. Yeah, and so it'll be at Tom's Watch Bar. This will be in the recording, so if you want more follow-up, you can review this part. Tom's Watch Bar at LA Live, so it'll be really close to the conference center. We'll have beverages, food, stuff like that. Also some new Syft and Grype swag, which will be cool. And we'll have a drawing for a drone quadcopter, so you can take observability to the extreme. But space is limited, so we have the registration link here. If you want to follow up and register there, so this will be in the recording again, anchor.com/2021-KubeCon meetup. Go ahead and register there so we know you're coming, and we can make sure we have the right amount of space for everybody. So that's all of our formal stuff. The poll should be closed for the or closing for the who's able to attend or knows they're able to attend. That should be getting shared out here momentarily. But I want to be sensitive to everybody's time. We'll continue on and be able to continue the discussion in a few minutes. So I've got time scheduled. I think others we can run long, but for anybody that does have to leave, I just want to say thank you to everybody that attended. You can join us on the Anchor side on Slack. We have our own Slack community. I know there's a Sigstore Slack community as well. So we have some links up here to get for the Sigstore and Cosign stuff on GitHub, as well as Anchore's Grype and Syft. So yeah, we're always looking to have contributors and collaborators on Syft and Grype. Would love to work through, if there's features that are really important to you, so I'm always open to work through those with folks. Always appreciate a GitHub star if you want to keep up with the projects. And if you're interested in speaking, have an interesting project or use case, that around Syft and Grype, or supply chain and vulnerability stuff, we're open to other speakers as well. So always open there, reach out if you'd like to present at a follow-up. Happy to have you. With that, I think we can formally end the agenda and then continue on to more Q&A and discussion kind of after the fact. And we'll, I guess we can continue the recording if we want to record the Q&A, if you want to follow up with the Q&A afterward. But our formal program has ended, and so we can go back to some questions with the Dans if we have anything we need to follow up on. So thanks all for attending. If you have to drop, no worries. Otherwise, we'll be here for another half hour or so. Availability as we can, and we can keep the conversation going. Okay, so now that we're kind of formally at time, you want to follow up on some of those questions, Dan Lorenc? I think we had a couple extra ones.
Yeah, so the next one was about revocation I saw here. Dennis, how does key revocation work? Yeah, so that's where a lot of those boxes and arrows on that slide that I jumped over really quickly come in. If you're just using the fixed keys generated with generate key pair, and you're not using the transparency logs or anything like that, then you're on your own for revocation. You generally rotate your key and stop trusting the old one and try to re-sign things. That's not a great model though, so that's where some of the other components come in. So Sigstore has a timestamp server and a transparency log, which you can use to help out with revocation. If you get your signatures timestamped by another party or published into a transparency log, then you kind of have a record of all of the signatures that you need to worry about. And if a key gets compromised, you can track down exactly which signatures don't need to be trusted and which artifacts those apply to. So it's a little bit easier to revoke the key and move on to another one because you have a record of all of the bad things and good things that happened. So there are a couple different models there depending on exactly which other components you're using. Next, actually, I think that's it. Other questions just about the blog. I don't see anything else.
Okay. Anything else? Any other topics or anything folks want to bring up? Is it getting supply chain processes in place in your own org? That's a whole other discussion topic, I'm sure. Okay. But the tools are coming a long way, and it's great to see this get the proper attention that we think it deserves, and we're excited to be working with the Cosign and Sigstore projects to kind of combine our expertise together. It's going to be an interesting journey, and looking forward to more collaboration between our groups. Thanks for coming and joining us, Dan and Dan.
Thanks.
Any other questions or follow? And people can feel free to speak directly. We don't have to do just chat. Otherwise, we'll give it a last call and see if we should wrap up.
Hey, other Dan, I have a question. Where are you seeing the most use of what Sigstore is providing value-wise in tools that are adjacent to Sigstore? So like, I'm curious, you mentioned the admission controller example. Given that you have the Sigstore infrastructure in place, maybe you're using the public recore or whatever, you're using cosign in your workflows, where are you starting to see folks consume those signatures to affect real change in their workflows?
Yeah, the easiest one is some of the Linux distros that do stuff like reproducible builds. So like Arch Linux and Debian and a few of the other ones are producing attestations, I showed here, that say, yeah, I rebuilt this and I got the same exact hash, and here's the machine that I rebuilt it on. I'm sticking those into the transparency log. So all the work that people have done over the years to make builds reproducible, now they're using these components to kind of publish and show that they actually reproduce things, because if nobody ever checks the reproduction of a build, it doesn't really help too much. So yeah, there's a community of people that are like rebuilding all the Debian packages and flagging if something happened and it didn't reproduce anymore, they got a different hash from what actually made it upstream. So I like to use those as an example because it's a way of kind of protecting anybody that's installing Debian packages without them even knowing about it, just because all these people are writing things to the transparency log and checking each other. If Debian repo ever had something in there, a binary that didn't reproduce from source, it would get flagged and we'd figure it out without you having to even know that stuff is happening. That's one of the coolest ones that I've seen recently.
When you say you wouldn't have to know what's happening, there's some point where you need to check the log, is that right?
No, so you're kind of relying on a couple of these other people checking the log. Okay. So if you're just grabbing stuff from like deb.debian.org, but there's 3 people that are checking all of those binaries and rebuilding and making sure that they match and putting those in the log, you'd be relying on them to kind of flag it and
I see,
publish it somewhere, basically, that hey, something doesn't look right in this binary. And you can check the log yourself if you want to as well. Some people have some automated systems that block updates on Debian until the build has been reproduced X times or something like that.
Cool.
Great. Excellent stuff. All right, and I'll do a last call for questions and then we'll wrap up. Any more questions, anybody? All right. See, I think Mirko, we had a follow-up for you. Do you want to? We can follow up with that in Slack before we end the session. It was around a question around Anchore and the commercial offering. Is that something you could join us on our Slack community, kind of follow up on? I just want to make sure we don't lose the connection here. Yeah.
No. Yeah, I can try that later. I'm currently on PTO in Austria, but yeah, I'll come back to you later because I'm working for GitLab and I try to understand, the differences in those things. Customers ask me, right? Mm-hmm. So yeah, I'll come back to you. Thank you.
Great. I put my email address in the chat here, so you can ping me there if you need to connect another way. Just want to make sure we didn't lose anything. Perfect.
Thank you, sure.
Great. Well, thanks everybody. Thanks for attending. Much appreciated. Thanks to our presenters for giving some great talks today. We'll be following up again. We'll get an email with the details on the recording, as well as we'll have the in real life. That will be our next meetup at KubeCon, and we'll have follow up after that. So we're getting into a regular cadence of these meetups. So looking forward to seeing you again, hopefully, and some of you physically, if we can. That'd be great. Otherwise, have a great rest of your day, and thanks for joining us today. So thanks all.
Thanks everyone.